Okay, so let's do a quick example of kind of navigating these output files. So just asking ourselves a few questions now that we've gone through a little orientation of these output files. So one question we might ask ourselves is, which atomic orbitals contribute most to molecular orbital 4? Okay, so in that case, we want to identify where molecular orbital 4 is. Okay, so that's going to be this molecular orbital here. Okay, so looking at that, we want to see, all right, which atomic orbitals are contributing the most. So we're just going to look at these numbers and pick out which ones have the highest numerical value. Doesn't matter if it's positive or negative, you're just looking for the largest magnitude. Okay, so looking at these, it looks like this 0.68 right here and this minus 0.68 are the largest contributors. So if we look over, follow that over, that tells us that these s orbitals are the biggest contributors. So one thing to note for Spartan's labeling is that this first s, they go in order of energies. So this s1 is going to be your 1s orbital. The subsequent s is your 2s orbital. Okay, even though it's not labeled explicitly as a 2s, we know that that one is coming after the s1. That's our 2s orbital. Okay, so here we have an answer of the 2s orbitals on each of our boron atoms. Okay. All right, so now we're asked to sketch the overlap of the atomic orbitals that we just identified. We want to include the wave function signs in the resulting shape of the molecular orbital, and then we're going to label it as Gerada or Ungerada. So we're going to put our skills that we just covered to work. All right, so let's see here. We want to sketch the overlap of our 2s orbitals. So one thing we want to double check is the sign on those orbitals. So the sign for the 2s orbital on boron 1 is positive. Okay, the sign for the 2s orbital on the second boron atom is negative. Okay, so these have opposite signs. So we're going to draw one as positive, and we've got one as negative. Okay, so drawing the overlap, there's not actually going to be any overlap between these two atomic orbitals. Okay, these are going to be anti-bonding orbitals because they're different signs. They're going to destructively interfere with one another. We're going to get a node right in the middle there. Okay, so that's going to be an anti-bonding MO for us. Okay, so we want to identify finally as G or U. Okay, so again, this is where we do our inversion symmetry. So when we invert these two orbitals on our atoms, the sign here is going to change. So that means that we're going to have a U designation. So again, remember your signs change upon inversion. Okay, all right, so we've answered that part of our question. Last up is MO4, a bonding or anti-bonding. Oops, already answered that up here. So just looking at this, again, we see that there is a node, okay, that happens because we've got that, again, that destructive interference between our orbitals. We're not going to get any overlap along our internuclear axis right here, which is where we want our bonding to happen. Okay, so we see we've got a node there. That tells us that we have an anti-bonding. Okay, so I think that is hopefully some good practice for getting you acquainted with working with these output files. Again, just highlighting some of the important pieces of information that you can obtain from these output files. Okay, so again, the different contributions from the various atomic orbitals on each atom, whether you get bonding or anti-bonding interactions, your symmetry designations, and then also we didn't talk about this explicitly in this video, but you also get your overall energy. So you could assemble your energy level diagram for your molecular orbitals. Okay, so they go low energy to high energy for that. All right, well, I hope that was helpful, and now you can go have some more fun looking at your Spartan output and putting together your energy level diagrams and your molecular orbital drawing predictions. So have fun with that. Thanks.